Hello, my name is RD and we are going to solve practice problem 4.10 from Hayt's book, determine V3 in the circuit of figure 4.28. So V3 is here and we are going to use loop analysis from here. Okay, this is I1, so that is also the current loop that goes through this one, right? So this loop here is I1. Now let's make another loop. Maybe this one is loop 2. So name this I2. And this one will be I3. But here we have a current source, so we need a super loop. Maybe let's make a green loop here. So this green loop covers up I2 and I3. And I will name this as super. So we can analyze KVL at Superloop and I1 because in those loops they do not pass a current source. Okay, let's do KVL at loop I1. Right? And KVL said the sum of a voltage will equal to 0. Okay. Okay, let's do KVL at I1. So the current here passing through negative polarity to positive polarity. So the sign will be negative. So I'll have negative 80 volt. And that current is passing through this 10 ohm resistor. So plus 10, but that is resistance. We need to multiply it by a current to get a voltage. So the only current that pass through it is I1. And for the next component, we have this 20 ohm. So plus 20. And again, we multiply it by I1. But here, I2 is flowing to the opposite direction. So minus I2. Okay. Then for this 30 ohm resistor, again, we multiply it by I1. But there, I3 is flowing to the opposite direction. So I'll have minus I3. And all of that will equal to 0. And we can simplify this using simple arithmetic. So 10 plus 20 plus 30 will be 60 I1. And for I2, I will have minus 20 I2 and minus 30 I3. And we can put this minus 80 to the right-hand side. So I will have 80. And we can divide both sides by 10. So I will have 6I1 minus 2I2 minus 3I3 is equal to 8. Yeah, I think we should solve this as equation number 1 because nothing we can do from here, right? And now we can do KVL at Superloop. Okay, let's do KVL and okay, I should use green here. KVL at Superloop. Okay, KVL said that the sum of voltage in a loop will equal to 0. And we should start from this 20 ohm resistor. So we have 20 ohm. But now we concentrate on I2 here. But here I1 is flowing to the opposite direction. So I'll have I2 minus I1. And we move on to this voltage source. And the current is flowing from negative to positive. So we will have negative sign and 30. That is already a voltage. So we can move on. And then we need to take care of this 40 ohm resistor. So plus 40. And the only current that pass through it is I3. So you have I3 here. And then for this 30 ohm, I3 is passed through there, but I1 is flowing to the opposite direction. So minus I1. And all of that will equal to 0. And now let's do some math here. So for I1, I will have minus 20 and minus 30. So minus 50. Minus 50. I1. And for I2, I only have plus 20 I2. Plus 20 I2. And then for I3, I think I will have this one, 40 plus 30, which is 70. Plus 70 I3. Yeah, I think that's all, right? Let's check. Okay. And then minus 30, we move it to the right-hand side. So I'll have equal to 30. And we can simplify by dividing by 10. So minus 5I1 plus 2I2 plus 7I3 is equal to 3. And let's have this as equation. Okay. Now we cannot do anything more, but we only have two equations for three variables. So we need some help from KCL. So maybe I will just use this node here. Let's name this as node A. And this current here is I2, right? This is I2. And this current here is equal to I3. And this current is just the value of this current source, which is 15 I1. So we can use KCL at node A. And KCL said that the sum of the current that goes in is equal to the sum of the currents that goes out. Okay, the currents that goes in will be this one here, which is I2. Okay, let's write I2 there. And 15 I1 also going in, so plus 15 I1. And then this I3 is going out, so I will have that equal to I3. Or we can rearrange this as 15 I1 plus I2 minus I3 is equal to 0. Okay, so now let's have this as equation number 3. We have 3 equations and 3 variables. We should be able to solve that. So I1, I2, and I3. You can use any linear algebra techniques to solve this, but the easiest way to do it is just using calculator. Right, so let's set up that. And let's do number 2. Okay, we will have 6 and then minus 2, minus 3, and then 8. Okay. And then minus 5, this one. And then 2, and then 7, and then 3, and then 15, and then 1, and then minus 1, and then 0. Okay, we will have the x value. X value is I1, right? Okay, I1 is 0 0.583. 0 0.583 milliampere. I mean ampere. And then I2, what is I2? I2 will be minus 6.154. Minus 6.154 ampere. Then I3, what is I3? I3 is just 2.604. 2.604. And the unit will be ampere. Okay. And then we are asked to find out V3. V3. What is V3? Yeah, V3 is just I3 multiplied by this resistance, right? Because of the Ohm's law. So multiplied by 4T. Okay, let's do that. So our I3 is 2.006 multiplied by 40. So I will have that one, 104.16 volt. 104.16, or we can round it up into this. Yeah, that is V3, which is the desired answer of this question. Yeah, it's the same as the answer key. So I think I did not make any mistake in the calculation. So thank you for watching. Hopefully this will help you to understand how to solve this problem. And thank you for watching. Bye bye. Do not forget to like and subscribe to my channel. Thank you.